All right, in this lesson, in this video, we're going to solve some systems of equations, and we're going to show two different methods here eventually. This one is going to be focusing on this method that's sometimes referred to addition method, but most of the time it's referred to as elimination. All right, so it's called elimination because you are going to eliminate a variable. So first big thing is system of equations. A system of equations is two equations. And there is a graph associated with this, or there's a graph to this, there's a graph to this. And that graph consists of all these points that make solutions to this. So x plus y needs to add up to 7. So like a 1 and a 6, a 2 and a 5, 5 and a 2. And all those combinations would make a line, right? And then this has its own set of solutions. So what you're trying to do on a system of equations is you're trying to find the solution that works for both of them. Okay, so visually, we'll talk about what that looks like in a second, but we're going to do the math. All right. Well, actually, let's do the graph, and then we'll talk about the elimination thing. So if we want to graph this, first thing that we need to do is we need to get ready to graph. So if we take x plus y equals 7, we need to bump this x over to the other side so we can get things more of like a y equals mx plus b so we can graph. Okay, so if we bump the x over, y would be by itself, and we would have a negative x plus 7. All right, so that is ready to graph. The slope on this is the negative right here. It's a -1, but we'll make it a fraction, so we have a rise over run. And then the b value, which is our y-intercept, is the 7. So we will start at 7, and then we will go down 1 over 1, because that's what the slope is telling us to do. Down 1 over 1. Down 1 over 1, down 1 over 1. And I'm going to put a lot of points here because I need, there's something that I need about this. So, and then if I go back to the left, that's the other one. Okay, so all of these x and y points are values that if you plug it into this original equation, they add up to 7, right? And then we'll do the same thing on the other one. We have x minus y equals 5. We're going to bump that x over, which just makes it a negative x. So we're looking at a negative y equaling negative x plus 5. Okay, so we don't want a negative y, so we're going to have to adjust all of those signs by dividing by -1, divide by -1, divide by -1. So y equals a positive x minus 5. Okay, so now this one's ready to graph with a slope of 1. So we'll make it a fraction to make it a rise over run. And our y-intercept is the -5. So we'll start at -5, and we'll go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. On. Then I can go down and to the left to kind of undo that. Go backwards in the pattern. All right, so that line represents all the solutions that when you take the x and minus the y, you're going to get a 5 out of it. So you have all these solutions for this graph, for this equation. You have all these solutions for this equation. And a system of equations is you're looking for what's a solution that works for both? And that's where they intersect. So then our solution is 6, 1. Okay. So, but that's kind of an inefficient way to do it. There's some limitations, like where does the graph cross? Or maybe it doesn't even cross at a nice coordinate. Then what do we do? So there is a faster, more efficient way, and elimination is one of the best of them. So what we do is we leave it in this form. This form's called standard form. We don't convert it. We don't try to make it into something we're going to graph, because we're not going to graph. So elimination is we are going to leave it in standard form, and we are going to line up your like terms. So the x, the y, and the constant all line up underneath each other. And what we do is we are trying to combine these equations. We're combining our like terms, but we also need one of the variables to eliminate. We need it to cancel. So right now, if we put the x's together, that's a 2x. And the y's will actually already cancel each other. There's nothing extra we have to do. So I'll put an elementary school equal sign look to this. We'll put the x's together, which is 2x. The y's naturally cancel each other. Then on the other side of the equation, 7 and 5 make 12. And then we can solve for x. Eliminating the y's allows us to solve for x. So we'll divide by 2, x equals 6, which is the same value as what we got over there. So anytime you know an x value, to find a y value, you can take one of these two equations and we can sub out the x with the 6 and see if it works. So let's say we take this because it doesn't have any minus signs in it. So we'll sub out the x. We'll make it a 6 plus y is supposed to equal 7. So if we solve that, we would subtract the 6 over to the other side, and y is going to equal 7 minus 6, which is 1. And there is our coordinate. Our x value is 6, our y value is 1. And I'm going to double check that it works. So I'm going to take that same 6 and 1, and I'm going to plug it into the other equation. We just used this to finish it off right here. I want to make sure that it works on the other. Pretty sure it's going to work on the one we just figured out an answer for, but let's make sure it works for the other one. So we replace our x with 6. The y, so it's minus the y value, so minus 1. Does that in fact equal 5? Yes. So that is the only combination that would work for both equations. There's no other x and y combination that would work for this one and work for this one. All right, so that was elimination. There's more, but that's kind of the basic idea. And the elimination is much faster, much more efficient than trying to get these things ready to graph. And then there's still some limitations on that. If they cross in a nice spot or not, where do they cross? How big of a graph are you willing to make to see where they cross? So graphing is a great visual, but it's not a very actually efficient way to solve it. So we'll do a couple more examples focused on that.